Mine just said you're recording already. Didn't we want to wait?
Yeah, I can pop. It's almost 6.
You mean, oh yeah, your time.
Oh yeah, 6 my time, 8 your time.
If I don't hear the ring, I'll read it.
Okay, well, as soon as my clock changes over, I'll press play here.
Mm-hmm.
Okay.
Yeah, I don't hear it this time.
Oh.
Join our book club as we discover how math helps us to know God. This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Leigh Bortons.
This is the Math Map Book Club,
No,
where
it's not going
ordinary...
to stop. There you go.
Hi, I'm Leigh Bortons, and it's Monday, January 16th, 2023. It's my brother Bill's birthday. Happy birthday, Bill. Welcome to the Math Map, where Kirsty Gilpin and I discuss a math concept each week from our soon-to-be released math curriculum for families with students and classical conversations communities. I really enjoy solving math problems, like other people enjoy Sudokus or crossword puzzles. I think it's because I like murder mysteries, which I watch and read a lot of. I'm always trying to identify the suspect. To me, a math problem is a relatively quick detective story where I can solve for whodunit. I think I like to find X. Kirsty, why do you like math? And you're muted.
I was thinking about that, and I was thinking that I think perhaps it's because I like things to be done and completed. I like to check things off, and so a paper might take you weeks before you finish writing it, but a math problem, even if you work on it for a few hours, usually you can get that sense of, I've got it, I solved it, and move on. So I think it's my check the box mentality that draws me to math.
Yeah, and I like how you said hours, right? Because math can be hard enough that you have to stick with it that long. And also they can be done quickly if you just enjoy puzzles. Okay, so this book club is a little different because we're studying a lesson a week from a math text over 30 weeks in 2023. We'll be taking the summer off, and the book club is scheduled so that parents who want to teach their children can practice ahead of time. So we're discussing the first semester during this winter and spring, and then the second semester next fall, hoping that you'll prepare to teach it next fall and then the following spring. Now, to access the math map, for those who haven't done that yet, you need to be a member of Classical Conversations, CC Connected Community. Please feel free to participate in the discussion, even if you are not in CC, as we will show pertinent information as we talk about math. So each week, we will consider a quotation that is part of our exordium for the math map lessons, and our PowerPoint will help us with that. Tonight, we're discussing what's called number notations and why they are so important. Kirsty, could you please read the quotation on the cover?
Sure. Nothingness obeys his voice by Richard Swenson. And when I was thinking about that and pondering it, it really made me think back to last week where we talked about creation ex nihilo, right? Creation out of nothing, that God spoke and everything came from nothing, right? And so this is just another way of saying, right, the same thing, that in the beginning there was nothing, but it was his word, which we then know became flesh and dwelt amongst us. Right, that it was his word, his voice, that pulled forth, right, that nothing obeyed his voice. And it just made me think about all the other times in scripture where we read about, right, the wind and the waves, obey him, and death obeys him, and things that, right, that it reminds me of when I was little, the first poem I ever memorized was by, I think, Christina Ricci, and it was, "Who can see the wind? Neither you nor I, but when the trees bow down their heads, the wind is passing by. It looks like there's nothing there," right? But it obeys God, right? So all the times that we may think that there's nothing, but all of it, everything is still under God's dominion.
That's great. So friends, that are listening, I want to know, what do you think about the reflection? What it makes me think about is that how often, because we're made in God's image, we create something out of nothing all the time. I mean, right now I'm conjuring my thoughts. I don't know where they are or where they live, and yet here they are coming out of my mouth. What are some other places where maybe nothingness obeys his voice, or you see that reflected in your life? And and we have Julie or Becky here tonight instead of Julie helping out. So Becky, feel free to let us know what people say if they chatted in.
So far, Simone said that she loves mysteries as well. It's fun.
A lot of times think about mysteries and how they're resolved. I mean, you got this police officer, detective. What questions do you ask? How do you know what you're going to do? I mean, it's a complicated process identifying somebody that's not in front of you, that hasn't left a lot of clues. And yet they conjure evidence, what's out of seems like nothing, but by the time they get to court, it better be something.
Yeah.
Anybody
So I'm
else?
speaking about the voice. Jesus commanded the demons that were in the man, the legion, into the pigs. So the demons obey his voice, and that's multiple times. There's other times that they obeyed his voice. Everything obeys his voice,
Yeah.
except sometimes humans.
Yes.
We're not so good at that.
Yeah, I just wonder in the long run if we'll find out maybe there was more to even our disobedience in obedience than we know. So.
Melissa Poole says, "I'm thinking of material possessions. We come into the world with nothing and we leave this world with nothing."
That's good. When you get and you recognize Richard Swenson's name? He also wrote a book that we used earlier in Challenge A when we're first starting to build the curriculum, called More Than Meets the Mind. He's a doctor or scientist who just loves thinking about nothing. And then another thing that's to note is week 2 is still in 0 dimensions, which is this is our last week talking about nothing. So if you have something to say, speak now.
Several people commented. Jen said, "We've been studying space and talking about how light from the sun travels through the nothingness of space to get to Earth and give us light and heat."
That's pretty amazing.
Right. And also Jill commented, "I love 2 Corinthians 4:13. We have the same spirit of faith. We believe and therefore we speak. Believing looks like nothing because it isn't tangible to the senses, but oh, how real it is."
Good. Okay, well, if anybody has any other reflections, feel free to chat them in to anytime for the rest of this book club. So I'm going to revisit with Kirsty a couple of questions from last week, just to have kind of the same format for a couple of weeks, and then we'll begin changing up some of these questions. But just to let you know, we've spent a lot of years discussing the difficulties of math education, and we have found there are many reasons for the difficulties, but they can be identified and they can be overcome. The first one being that math is a foreign language, and we're going to talk a lot about that later tonight with number notation. So I want to skip that one for now. But the second reason is because we say math's orderly, but we really don't know what the canon of the order of math is. And so Kirsty's going to be talking to us about a PowerPoint about a different slide, or with a slide about more of what is in the math map and what makes it a math. So Kirsty, take it over.
So as you can see on the behind, that is actually what we call the math map. And it is really a way to chart your journey from your mathematical infancy to hopefully some degree of math mastery over the course of 13 years. And so the first thing that we thought we'd draw your attention to is that really beautiful colored bar along the top that's labeled domains. And mathematically, a domain it's just a set of values that you can use in a problem. So for example, if you're dividing, you might say, well, you can't divide by 0. All right, we talked about that a little bit last week, that depends on what you're doing, what dimension you're in. But as soon as you say, don't use this value, what you're saying is that's not in my domain anymore. What numbers can I use and what numbers can I not use? And so instead of creating grades, because we know that with homeschoolers, everybody is in a little bit of a different place. We wanted to create levels that better reflected what students needed for their math journey in any particular year. And we did that by saying each year we're going to use different numbers. So our youngest students or our parents who are just now getting familiar with the math map might use natural numbers. And then once you become confident with natural numbers, you can move on and do the same problems with integers. And then notice there's 3 years working with decimals and fractions. One of the things that a lot of people seem to struggle with are those calculations with decimals and fractions. We've got 3 years. And then finally, our Challenge A students are going to be working with complex numbers, which means they're going to use every kind of number that's out there before our Challenge B and above students start doing some more algebraic manipulations. So notice again, I'm saying that we're talking about the same thing every year, just with different numbers. So if you are struggling with something and you're finding the numbers are really confusing you, you can use a different domain and find some numbers that are more comfortable and more familiar. Gain that familiarity with that number, and then just make it one step up to a different kind of number. And so that's what that domains across the top is. There's 13 to represent all of the ages that may be in classical conversations, from our BCDarians to our Challenge 4 students. And again, it offers that flexibility of saying, hey, I'm really struggling with these complex numbers. I think I need a little bit more practice with real numbers. So it gives you that flexibility to adjust the curriculum to meet your students' needs.
Yeah, and something I'd like to add is that, when people ask our children what grade they're in or what they're studying, and a lot of times they don't really know how to answer us. And that's because they're kids. I mean, whether they're not paying attention or now they're homeschooled and we don't talk to them that way. But what I'd like to have our community doing is, at foundations for the children to not think I'm in 4th grade math, but to say, you know what, I'm studying fractions, or I'm studying rationals, or I'm studying, and be able to actually name what they're studying for an entire year, that they have that opportunity to get familiar with those domains. But speaking about the domains and the various numbers they represent, Kirsty, I was wondering, since this is our last week talking about ex nihilo and 0, could you tell us about the controversy with the idea of 0 and what domain it falls into?
Sure. So, of course, if you read the history of 0, it's really interesting in and of itself, because as I asked the master's students this question, right, if we don't know something, can we really understand the absence of it? And so then you're also curious, is 0 a number, right? What else is 0? It does so many things for us. It's so important. But for a long time, 0 wasn't included in mathematics, and then it was. And even today, people really disagree about what number set 0 fits in. Some people say it's a natural number. Some people say it belongs in the integers. But for the purpose of the math map, it was just a lot simpler for what we were doing and for our students, to decide that 0 was a natural number. It is in line with what other people do, as long as you define it. And so we have defined 0 to be a part of the natural numbers for the math map.
Okay, so other people could say it's an integer, but would other folks ever say it's not a whole number because it's nothing? What would they say?
Usually I think people either fall on the line of, yes, it's a natural number, or yes, it's an integer, nowadays. Now, if you go back a few hundred years, you probably would find some people that might be willing to argue that it didn't belong in either one. But nowadays, I think most people define it as being one or the other.
Yeah, and something I think that's interesting is that the number 0 wasn't used ubiquitously across the globe until after or around the time that Leonardo da Vinci invented double entry accounting, along with some other folks around that same time, because you have to have place value and a 0 for the for just business in the way that they were keeping track of things. So there's just a lot of interesting history to 0, because then I think, okay, so they've only been using 0 for 500-600 years. What did they do before that? Well, I guess the answer would be, why would you count nothing? So, okay, so contrast infinity with 0. Is infinity a number the way 0 is a number? How are they different?
So infinity is not actually a number. It's more a direction of where you're going, right? So you've got positive infinity and you've got negative infinity. And I think it's interesting because when we talk about big numbers and small numbers and limits, they all have to do with 0 and infinity, right? That if I'm talking about really big numbers, I'm talking about things that are zooming out to infinity or negative infinity. They're far away from 0. And infinity just says, keep on going, right? I can never get to the end of the numbers, right? If I counted for all of my life and then my children took over as counters and their children, right? Until the end of time, until Jesus comes back, we would never run out of numbers. And we can count positively or we could count negatively. We're never, ever going to run out of numbers. We could even count by thousands and we would never run out of numbers. And that's what infinity does for us, is it tells us this idea that of the direction that we're headed without end. Now,
And then, okay, I'm sorry.
I was just gonna say, we can also talk about infinitely, right? Because infinitely says, whatever I'm doing, I keep doing it without end. And so when I think about a small number, I'm talking about getting infinitely close to the 0. I can never be 0, but I can get infinitely close, which means however close I think I got, go closer, and I can still go closer, and I can still go closer, right? That idea of you can keep on going, whether we're talking about infinity as a direction or infinitely as an adverb.
Good. Okay, so that makes me want to remind the listeners that they're welcome to participate. So if you have had any ideas on that reflection that have come to you while Kirsty's taken or been talking, but I would also like the club to discuss what is the difference between infinity and eternity. If you had any insight to that. And then if any of you have a question about the domains, now would be a good time to ask.
My initial reaction to infinity versus an eternity is infinity is speaking dimensionally, whereas eternity is time specific.
Yeah, because Kirsty said infinity has a lot to do with the direction. Anybody else? How would you explain it to your children, the difference of infinity versus eternity? I love Lindado's eternity's forever with God.
Any other thoughts? guys. Jan says infinity continues throughout eternity. And Lynn says infinite number of things versus the eternity of time. And Simone says counting versus time.
So Kirsty, anything you want to clear up for us, or are those good analogies?
I think those are good analogies. I'll just share this. I don't know if this is the most appropriate place, but I was looking up some different standard units the other day, and I came across an article that was claimed to have all of the units used in the Bible. And the argument was, we don't need metric because we'll just use biblical units. And I was looking at the list, and I was thinking of all of the customary units and the standard units and metric and so forth. And as I looked at this list of biblical units, one thing stood out to me. The only unit that we still use that was in the Bible were units of time. And it made me think of it in Genesis, right? That God says that he put, right, the sun to measure the seasons, that God instituted time, and those are the units we still use. And so when we think of eternity, right, we think of it as being a biblical world, this sense of foreverness where God is, right, in eternity, time past to time future. And it just reminded me that God not just determine the number of days we have, but the rhythm of those days, the seasons that we go through, that time is under the Lord's dominion, and we still measure it the way that he established in the Bible.
Could you explain for us how ISI, the International Standards Institute, uses time for all of its measurements?
Well, it is interesting because they measure they use the vibrations of a cesium atom, and they're talking about possibly upgrading that, but they use the vibrations of a cesium atom to measure a second. And then they look at how far light travels in any given amount of time to figure out, well, that's what a meter is, and so forth. So it is very interesting when you start researching the standard units and how they're determined, especially when you think of how they used to be. You know, this is my arm, and those were my feet. That we've become very, very precise.
Yeah, and so we can talk about that some more next week in chapter 3, because it's in or booklet 3, because it's in that chart. But there's only 7 standards of standard measurements that everything is built off of. It's interesting that it's 7, and 6 of the 7 are actually time related. So we'll have some more of that conversation for next week. So if any of you are interested in looking at the ISI standard measure of units, it's pretty remarkable. And what you brought up with the time being the same thing from the Bible that we use, I don't know, it's just cool. Okay, so
there is a domain question, but I think it ties in here to your next segment. You want me to go ahead and read it?
Yeah, you might as well. We can use it to introduce the next segment if we want.
Okay, there are 16 worksheet pages per week posted for the naturals. Are those 16 pages intended to be completed over a 4-day school week? Or are there different worksheets posted for different levels of comfort with the material?
I'll let Kirsty answer.
So yes, so for each domain will eventually, let's see if I can, right? So eventually, finding that magic focus here, there will be booklets, right? So that every week we'll have a booklet, and notice that the color on the booklet actually matches, in this case, the complex. So if this was the naturals booklet, this would have a red bar, and here's the cover. And when you open it up, there's 16 lesson pages that are designed to be done in those 4 days. In our guides that go along with this, that will be available for parents when this is eventually released, we have a lot of ways that parents can actually tailor those 16 pages to meet the needs of their students. And then additionally, right, you can actually use a different booklet. So maybe especially in the arithmetic units, which is the first dimension. Maybe I'm really just struggling to work through the rationals level. So maybe I'm going to go back and revisit the fractions level and make sure I know how to do fractions before I try to move up and do the rationals level, right? So it is another way that I can tailor the curriculum using those different booklets. I hope that answers the question.
So that question was from Beth. Beth, did that answer your question?
Yes, that was super helpful. Thank you.
So Kirsty, could you maybe share with us a story you told me earlier today about a parent who was frustrated with the curriculum, and then she listed what she does, and that made you so happy? Can you share that with us?
So we have really been, I think I'm going to preface it by saying this, that we have been very conditioned to think that math is all about solving problems, that you have a page of exercises and you work through the exercises. That's your homework. That's what you're supposed to do. And what we heard from this parent was that they spent so much time looking up the words, making sure they understood the words, essentially, as I was talking about last week, decoding the page, reading the page and understanding what they were doing, that it didn't leave them very much time to work on the problems. And so they would only get through a couple of pages each day. And I was like, but that's the whole point, is to work on reading, to look up the words you don't understand. We want to flip mathematics on its head. And instead of saying problems first and then flip back if you're getting stuck, read it first. Do you understand what the words mean? Do you understand what the symbols mean? Once you understand that, now you go and work on the problems. So that, to me, I heard about the story secondhand, but I wish I could have talked to the parent myself and said, no, that's perfect. That's what we want everybody to do.
Yes. Yeah. So we have high expectations of understanding, but I don't want to say low expectations, but maybe realistic expectations. It's going to take a long time for us all to get there, because we really are trying to change math culture. And, one of the reasons we gravitate to getting the problems done is when we start off with just natural numbers and the simple calculations, we're all pretty good at it and pretty fast at it in general. And then when we're asked to slow down and read things, it's like a whole new paradigm, and we don't want to do that. It's like, well, now it's hard, or now it's unfamiliar. So we want to help parents to reverse that process by becoming familiar with the number notations themselves. So let's jump right into that part of the discussion. While we're doing so, it looks like Becky's doing a good job. You guys have got the gist of it from last week, but feel free to chat in any kind of questions at the bottom of the screen, or raise your hand, and Becky will call on you. So the number notation, why should all math books begin with a review of numerals and symbols, the number notations, Kirsty?
Well, first I'm going to apologize because I'm the one that updated the slides and I didn't do the blue side. So I apologize to everybody if you're confused, but I think that it's
because it says ex nihilo, you mean?
Yes.
Instead of number notation? Okay.
I think it's really easy for us to assume that we understand the simple things deeply instead of stopping and making sure that we think about the simple things deeply. And it's really easy to, especially as students get older, to assume they know what numbers are, right? We've been dealing with this for a long time. You know what these numbers are. Instead of pausing and saying, do we really understand what the numbers are? How do we understand them differently this year than we did last year? Because if I don't understand what numbers are, then everything else is going to be a struggle. And so really pausing and taking time to think about numbers, to give students the opportunity to say, I never really understood what a fraction was, right? Well, that's a possibility. When we're dealing with 8, 9, 10-year-olds, right? They get through a year and they go, it never clicked. Well, let's go back and let's make sure we understand, because these are the tools. It would be like going to, if Leigh hired me and said, come in and you're going to be a part of my construction crew today. And I had on my resume that I've been working in construction, but I didn't say that it was like dollhouse construction. And now I'm going to work on a real house. And if Leigh doesn't say, okay, I want to make sure you know how to use these tools, and instead of just sends me off. And so now I have a screw and I'm trying to hammer the screw into the wall, and she comes over and she goes, wait, what are you doing? That's not the right tool. Well, it's the same thing with numbers. We need to understand our tools, and taking that time at the beginning of a year to say, what are my tools, and do I really understand how to use them correctly and when to use them? I think that's really important.
Okay, so before we continue the conversation, I just want to thank our sponsor, ccconnected.com, where the math booklets discussed by the club can be downloaded by Classical Conversations members, and encourage you to look ahead to the book club schedule. It's on leebortons.com under the Math Map Book Club tile. It's exactly the same as the slide that Kirsty just showed you. So next week would be lesson 3, which is called comparison. If you get any time, go on to CC Connected and download it in black and white, and then review it yourself as an adult. I asked one mom how she reviews it. She's been keeping up with it for herself. And she said she goes online and she does as much as she can without printing off a page, and then will print off the 2 to 4 pages that she feels like she just has to practice more or doesn't quite understand. So if you're doing it for yourself, we trust you to work through it whatever ways possible. And I'm hoping that people who aren't in Classical Conversations will eventually join us if they haven't already at this book club. Don't feel like you have to have the booklet reviewed. You'll see we're going to just talk about math ideas and show a little bit each week of small parts of the math map, so that those of you who are working through it, we can share some of the highlights of why we enjoy mathematics so much. Okay, so remember, next week it's lesson 3, comparisons. All right, now we're ready for the club. Questions from anybody? And if you don't have questions, Kirsty and I have the topic of place value we'd like to go over with you. But Becky, are there any questions first from the guests? We're happy to, or from the club.
There's not a question. Donna just made a statement. Donna, do you want to chime in?
So my degree is early childhood education. And in the math class, we were taught that, and we talked about number permanence. And I heard Kirsty talk about it earlier today in our class about the 3-ness of 3. You have to understand that 3 is 3. And so we were even taught, like put 3 little blocks on the table close together and ask the kid, how many blocks is this? And they'll count 1, 2, 3, and then just spread them out. And if the child has to recount them, they don't understand that 3 is 3. So they can't understand that 3 plus anything is going, because they don't understand that first. And I think so many schools and so many parents were so eager to get our kids to addition and subtraction and solving those problems that they don't even understand that 3 is always 3.
Yeah, that's really good insight. And so for those of you that might be curious about the math map related to that, Kirsty did some research before we even really began, and found out that in general, the human mind sees 4 really fast and easily, no matter really how much you practice, it just does. But to get to 5, you kind of have to practice it. So we have a lot of practice of just looking at 5s through the first 4 domains, to give the students that opportunity to develop that permanence Donna's talking about, or one-to-one correspondence is another skill that goes with that. And the thing is, with decimal being the base that we do majority of our work in, 5 is a good segue to 10, right? Because if you can see 5 twice, you see 10s. And of course, God gave us each 2 hands with fingers and 2 feet with 5 toes each. So getting to know 5 is a really important step of getting to know 10, because it's also half of 10 is another number that's important. So I just wanted you to be assured that we've done our best to research just brain functions and the eyes and how they see things, and how you establish permanency and those kind of things. Thanks, Donna. Anybody else?
Oh, next, Sherry was helping clarify the booklet for next week. That is comparison.
Thanks, Sherry.
We did have a few other questions back on the infinity versus eternity
Go ahead.
conversation. Well, Sherry said eternal is existence without beginning or end.
Ah.
Infinite is limitless in measure.
Does it have beginning and end? Infinity?
Eternal is
I'm
I
just
felt
wondering.
like eternal was more of a being, an existence, whereas infinity was a measure of something's of something in this, especially in our third dimension.
Do you think infinity is a quantity that's not a number? Or is it, what is that?
Yeah,
Or is
that's
it
what
only
I'm trying to
direction?
wrestle with, if it's a quantity or a direction. Yeah, but eternal just feels like existence. That's how I differentiated it.
When we use the word like existential crisis, we mean a crisis for our time,
Mhm.
right? So it relates back
That's
to
true.
that.
All numbers, both direction and quantity.
What would you say, Kirsty?
Wait, it didn't come through clearly, Donna. Can you repeat that?
We're all, so she was saying like it was direction versus quantity, or I don't remember the word she said, but quantity. So aren't all numbers both? And that's where we get into that struggle with zero sometimes, is that zero doesn't have a quantity, but it does have, it's the origin for direction.
Well, it's interesting because that's where, right, in 0D, where we are right now, it's just a number. And it's interesting because we want to understand zero as being nothing, but really in 0D, it's just the number zero, and 3 is 3 and 5 is 5, and they don't have any comparative meaning in 0D, right? And so zero is zero. And if you said draw a picture of zero, I can't, right? I can't illustrate zero because it's just zero. But it's just a number. It's not really until we hit those other dimensions that we suddenly start to go, oh, zero is like super cool because of all the things that it does for us. And I think as far as infinity, it's not an actual quantity. I think direction is probably the best because you're talking about where you're headed, right? That there is no end. It's almost like a place, but it's not a fixed place. That's why I would say it's a direction, right? It's where you're going to that doesn't, but you never really get there when you talk about infinity.
Let's pick on like the number 4. So in 0 dimension, you can have 4, but you can't have -4 or +4 until you're in 1 dimension. And then it has what Donna said, both direction and quantity. Is that accurate?
That's accurate. Yeah, we can talk about -4 in 0D, but we don't understand it as direction until we hit 1D.
So for those of you that know the 5 common topics, that the dimensions really lend themselves to circumstance, because the range of answers can be greater with each dimension. Each dimension going from end dimension back towards 0 limits the kind of answers that you can have. So that was really interesting to me when Kirsty first pointed that out to us. Okay, anything else, or you want us to jump into place value now?
One more comment from Cindy. She says if infinity is directional, eternal might be a state, but the Bible does talk about where we spend that state in directional ways, heaven above, hell below. So the state of eternal perhaps has an infinite quality. It was fun. That's good.
I'm going to throw this out there, Leigh. I wonder if eternity transcends dimension.
Well, I suspect it does, but the Lord's kind to let us take the dimensions he stuck us in and try to understand him better, right? Right. Yeah,
That's good.
I think eternity probably does transcend them. And yet
Infinity infinity sort of describes each dimension, right? We can talk about the dimensions one at a time when we talk about infinity, but eternity sort of transcends all of that.
Right. Time of fourth dimension, Donna, we treat it as such in the math map. Once you get to four-dimensional calculations, they're almost impossible to do, even at the collegiate level, except for in matrix math. So what we do is reduce, or we substitute that fourth dimension of space with the dimension of time. So we're still dealing with four dimensions, but it's a place where we can put in rates and motion and calculus and still have it reflective of the universe we live in. So good question.
Okay, I think that's most of the comments for now.
All right, I want, Kirsty, if you don't mind, let me introduce place value and then you can finish us off with this chart. So our place value is base 10. We have 10 digits, and I'll just say them because I can't see all of you, but you'll get them 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's base 10 or decimal, right? Desa meaning 10. So if you had base 9, not base 10, your digits would be 0, 1, 2, 3, 4, 5, 6, 7, 8. And if you had base, just for time, let me jump down, base 6, you would have 0, 1, 2, 3, 4, 5, because remember the 0 counts as a digit. And so if you have base 3, you have 3 digits. The base tells you the digits, and that would be 0, 1, 2. So one of the things we help the students do in the math map is to notice the digits that they can use in the various circumstances based on base. Now, they don't do multiple, or they don't do bases besides base 10 calculations until they're in the challenge like B and on. But we start to introduce them to the idea that that base matters and how base works. So when we're ready to introduce the other bases, they've begun to think this way. So Kirsty has a page here from the chart that she's going to go over. But the one place where people get hung up is how do you count in the other bases? And this chart may or may not, in the short time we have, help you. But this is one of the places that we'd identify as one of the more difficult ideas that is in the week 2. And if there's a place for you to spend time, we suggest that it would be on this. And so let's just, you guys can see this. I'm going to just say we're going to count in binary. So I would say 0 and 1. And then I'm done. So I can't say the word 2. So once I am in decimal and I want to go up to 9, the next number in place value shifts. 10 takes 2 digits, right? So when I'm done with my digits, I shift. So if I count 0 and 1 and I'm out of digits, I have to shift. So then the next number is 10, which looks like a 10, but it's really 2 in binary. So I would count 0, 1, 2 in decimal, or 0, 1, 1, 0 to get to the next number. So Kirsty's going to show this with the visual. And it's that shifting is usually where people get hung up on how place value works. And for the littlest kids, just work on base 10. That's enough. But it really helps if the adults in the room see where you're going. Okay, Kirsty, you want to tell us?
Sure. I'm going to try and use my fancy tool. We'll see.
And then ask why not 0, 1, because 0 and then the 1 is just 1. All the 0, 0, 0, 0, 0, 0, 0, 1 is still just 1. But zeros after 1 change things, right? 1's and then 1, 0, and then 1, 0, 0 would be 100. Okay,
so when you think back to Roman numerals, and a lot of kids like to play with Roman numerals, it's an additive system. I add what's there or I subtract depending on, if they're in front or the back. But with the number system that we use, it's positional. And that's one of the reasons why 0 is so important, because it helps us to keep track of the position that a number is in, because depending on where that number is, determines how much it is. And so that's when we call place value. It's your place. The place of the number has a different value. And so on our on this inset here of a chart, I'm just going to mention, Leigh, that in the booklets, eventually there's 4 charts each week that have essentially all the grammar that you would need throughout the whole program. And so it's really a picture of our goals for our transcendental students, but it's included as a reference for parents. And so this small piece on the screen, what you see behind it is what the whole chart would look like. And then this is just a small piece blown up for the purpose of tonight. So if we let's look at base 2, because that's what you were counting in. When we look here, you can see that very first digit is worth 1, right? And so I can have either 0, 1, or I can have 1, 1, because as Leigh pointed out, if I have 2, notice what's next to it are the 2s, right? So as soon as I have, and I'm going to just draw over the numbers that are here, as soon as I have 2, I have 1, 2, and I have 0, 1s, and that's what looks like the 10. And I can keep counting, because I could then say, okay, well, now I have 1, 1, 1, 2, and 1, 1. And because we're familiar with decimal, we always go back to our decimal and we go, oh, okay, well, that's 3, right? But in base 2, it's just 1, 1. And the nice thing about this is it works the same for decimal and for base 2 and for any number, is that I'm always going with, like if we look at base 10, right, I have 1. So in this example here, there are 8 1s and there's 1 10. Well, if I add 1 10 and 8 1s, I have 18, which is what we can all read as the number. Well, if I was to keep going until I had 10 10s, well, I can't fit 10 10s in here, but I know that 10 10s is 100. So if I had gone up here until I had 10 10s, I make that new space that Leigh was talking about, but now I have 100, which is no 10s and no 1s, but just 100. And so it keeps going up. And because of that pattern, the way it goes up, we can also express this using the powers of numbers. So 10 to the 0, which is 1, 10 to the first, which is 10s, 10 squared, which is hundreds, and that pattern continues. And if we go down and look at base 2, we see the same pattern. 2 to the 0 gives me my 1s. 2 to the first gives me 2s. If I had continued after 3, if I add 1 more, well, if I add 1 here, this becomes a 0 again, because I'm going to make that here. But now I would have 2 2s. Well, I can't have 2 2s, so I have to have 1 4, right? And so now it progresses, and we're going to move a lot more quickly in base 2 than we would moving up in base 10. But the beauty about this is the patterning, right? That we can see if we just keep going up here, all of my indices continue, my exponents continue going up. And notice on this side, they go down, right? So I have 0, and then I have -1, -2, -3. And so all of my values are based off of that base. And so that's what that bottom example shows you, is that I can pick any number here and I could build a place value off of that number. So I could have base 32 if I wanted to, or base hexadecimal, base 16. And what do we have to do there? If you're familiar with that, is because we run out of digits, right? If this was 16, well, I'm not going to write a 15 here and then a 14 here. That would be really confusing. And so what people did, they said, well, let's use letters. So 10 is A and 11 is B, and so forth. And so hexadecimal becomes a mixture of numerals and letters that represent numbers, so that I can actually go above 10 in one spot. So this was fun. We could keep doing this, but I think we'll run out of time.
So that's just a quick overview of what's in the number notation, as well as, and we picked a harder thing on purpose just to give you that heads up. So if you didn't get to do it this time, you might want to download the pages in the beta that practice. place values so you can get started understanding that system. And with that, you know what? We're out of time. Are there any other questions there we need to answer, Becky, or?
Not
you
right
good?
now. I think we're good.
Okay. Well, Kirsty, I appreciate you explaining that to us. It's going to take many times over and over. We'll revisit it again. And we know that learning the language of math helps us to see the unseen. So take advantage of your CC membership. Prepare yourself to redeem your love of math, and see you next week. Thank you. Bye, everyone.
Night.